Right, well today we seem to have got sound. Right, we've got an immaculate Communicator NI440DX in for service with some kind of power lead. I think it's the yellow meter that's the early one and the clear meter that's the later one. It's got a bit of a power lead here. It's not quite there, but it's not far off there. It's difficult to get the right power lead these days. Workmen in the United States do a replacement lead, which is somewhere near, but when I inquired of Workmen if they would supply me as a dealer in the UK, they said it provided my orders were £10,000 or $10,000, sorry. So that wasn't going to happen. So here we go. You can cram in a Cybernet power lead, but it'd be non-polarised. It'd be something you'd really have to keep an eye on. Right, we're going to. I know this isn't a dead set because it has come in from another dealer who's losing the ability to use his hands with rheumatism, so it's not his inability by a long way. It's physical. He's retired anyway, but that's nevertheless something he probably wants to do for a long time into his retirement. But you know, I think myself as a church organist, and I'm now 60, that could happen to me, which would put a spanner in that works. It'd put a spanner in this as well. So far, we've managed to be all right. I've not got any nasty gnarled fingers yet. The very famous theatre pipe, the pipe organist, theatre pipe organ at Blackpool Tower, Reginald Dixon. I think he was 55 when he decided to retire because of rheumatism, because he didn't want to go on playing dreadfully, hitting all the wrong notes, and be remembered as somebody who played dreadfully. So he did retire at 55 from that work, and that's you know, so it can happen to anybody. Of course it can. So these are a bit of a swine to set up on receive. Pop the speaker off. Carefully put that on the piece of polystyrene which is up there. I think Americans call it styrofoam, don't they? Switch the set on. So we've got those off. We want RF gain up. We'll have the tone up. RX light is lit. Plug the mic in, which is the original communicator mic. I know some people hate these sets, but I think it's down to the fact that most of them aren't aligned properly. That knob should line up saying communicator that way on, more or less, when it's on channel 20, so that's now in the correct position. So I'm going to switch picture in picture on, and hopefully we'll be able to see something if I put the right camera on. I'll just get up because I just can't see the monitor from. When I had the previous system with the Sony 9-inch CRT monitors, I could see them from a good angle, but with a flat panel monitor, I can't see diddly squat. What I therefore need is HDMI to S-video, then I can use a CRT monitor. I wonder if such a converter exists. Think about it, folks. HDMI to S-video. So, we're on. I'll go into transmit. Let's see what we've got. Before I go into transmit, we better plug the test equipment aerial in. And test equipment speaker. That sounds like the one that's hissing. No, that could be the PA one. That's the one. And that sounds wrong straight away. The receive sounds wrong. And that's what these are normally going to be like. I don't think they often do 4 watts. And this one at the moment is doing 2.8. It really doesn't matter. But we'll bring that up to what we can. So it's communicator. It's LCL, by the way, with the importers. It's Communicators NI440DX. Doesn't say LCL anywhere on it, but if you look at the ads in the magazines, it was LCL who were doing them. And of course we do know there's the Mana Kestrel and the Sapphire, is it 4000X? Or no, it's Serpent UK 4000. And when you look at the bottom of the board, if I took the bottom cover off, the printed circuit board has etched on it UK 4000. So there you are. So it's what did I say? I've already forgotten. Well, give it 2.9 watts. We'll say it would be generous. So let's go over to the frequency counter. I'm kind of cleaning records at the same time, so I'm going to keep jumping up and pausing the video. 2779089. So it wants pulling up. I'll tell you what, we'll do that right away, but the test set's only been on for 10 minutes and it's best if it's on half an hour. So we'll just do that. With the trimmer just there. It's yellow in these sets. There we go. So that's that done. Let's look at deviation. Wall. Am I reading this right? Wallow. It's 1.5. It's not being messed with. And now we'll look at the receive. So I'll just set the signal generator to the required frequency of 2779125. Right, see what we've got. Well, that's 1 microvolt, folks. Let's go to the SINAD meter. So the receiver is as dreadful as I guessed it was going to be. Oops, overshot that, but I really don't care. So that's about our 12 dB point. Let's go to the attenuator and look at where that is. So it's actually, we're on the 10, and so it's 5.5 microvolts for 12 dB SINAD, which of course is absolutely dreadful. So it's going to have been screwed up because it doesn't tune up like most CB sets. It doesn't have the, I think it's this set which doesn't have the clever FM chip. But anyway, I'll get the service data out and I'll come back to this in a moment. Right, I've worked out what's what from the circuit diagram once again. I'll try and remember to scan it and save it this time. So we're going to start. Chucky on my cup of tea as well. Just start on the first coil there. L 2, 3, 4, 5, 6 and 7. I'll put the soldering iron on ready to melt the wax in that one. So here we go with transmit. So I'm going to stay on the 3 watt scale initially when I show you the right meter. So just about a full deflection. It's actually come up to 2.9. So that's not really made anything. Neither's that, so these are correctly set. Bit there. Let's get rid of the wax. Go over to the other scale. We're just at the 3 watts. Check none of those are being messed with. Now out of interest, I know it's not my set. I'll just wind the power up on the power supply. We're at 13.8 volts. Now my Nissan Leaf charges at 14.4 volts. So I'm just wondering what the implication of that, for example, is. So we'll just screw the power supply up slightly. Voltage, there we go. So at 14.4 volts, let's just see where we are. We're at 3.2 watts. So that's fair enough. So don't get worried about this because it really makes so little difference. It's not a problem. You can mess with the ballast resistor, but whatever you do, don't link that out, or you'll end up with the burnt out output transistor, and you probably end up with half the signal on an aircraft band like these Wallies do with the Amstrads. I got a zillion watts out of an Amstrad. I've done that demonstration to you. And they're linking out to the ballast resistor caused the radio to do 2 watts on 27 megs and 5 watts on aircraft band about 111 megs. So on a cheap power meter, whoa, yes, look, it's doing all these watts. Yeah, but they're not on 27 megs. So that is the transmit. Let's look at the meter. Now, although we know the set's doing 3.1 watts, the meter still needs to be in the centre of the red zone. I know it's all a load of bull, but that's how it is. Transmit meter adjust is, I think it's that one at the back. I'll just get some more powerful reading glasses on. Yes. And low power, is it adjustable on these? Don't think, yes it is. I was going to say I don't think it is, but it is. So on low power, we should be on, where is it? Oh, it's a switch at the back. It should be 0.4 of a watt. It's 0.47 of a watt. And it's the adjustment just there. There we go, 0.4. I really missed low power on modern radios. 2781 had that and it was fantastic. Right, deviation. We need to bring it up. So it was at 1.5. Deviation is that one. minute, that's not doing anything. Because I'm not on the right thing on the test set. Wallow, spot on. Yeah, I was still on power on the test set instead of moving it over to deviation. Just remove the tool and try again. Wallow, there we go. 2.2 average, 2.5 absolute peak. Alright, we'll start on the receive. I don't know if I'm going to have time to go through all this, but I'll try my best. I'm going to put 20 minutes in today, and I'll try and put 20 minutes in tomorrow. Right, we'll probably I'll try and do all of the set, and then I'll just do the running through I'll put it together and do the running through the channels tomorrow. And tomorrow's Sunday, and of course I'm very busy with church, with my main job being as a church organist. Right, receive. Well, we know it was absolutely dreadful. So, let's check we're still on frequency. We are. And we'll go over to the SINAD. No, we'll go to the oscilloscope first. I'm going to put an S9 equivalent signal on. Like that. And we'll adjust the detector, which is L17 up there. And that was already spot on. So that's not the one which is messed up. So we'll put the SINAD meter now to about 4 dB. I'm just going to very quickly run through these to see what's really amiss. So quickly go through them, drop the signal generator off. Drop the signal generator off. Drop the signal generator off. There we go, right. So we've come down a long way, but we're far from being right. Just going to check the IF injection is right. I think the answer was no. I think the easiest thing to do is to use the 455 signal generator just to get us into a quick, because it's so messed with. He's trying to get it somewhere near. So I want the 455 one, I think. So it's system load, that one. We'll just plug something into there. Turn the tone off on the signal generator, the main one. There we go. Turn that off. Put the other signal generator back on. So we're now at 2.4 microvolts for 12 decibels. So we've come down from 5.5. So we've definitely got an improvement. And it actually sounds more correct. So we'll go through the front end again. So let's see where we are now. We're now at 1.2 microvolts for 12 decibel SINAD. Once we get under 1, it's acceptable. So I think we've got that right now. So once again, I'm going to check the detector. With all this being interactive, that's now adjusted differently. So one final go round on the front end. Right, let's just go through these IFs. So once again, I'm going to check the injection level. And that's got 2 lock points. So which one's the right one? Put a bit more signal on. I think it's that one. That could be on a false point too. So now we're at 0.5 of a microvolt for 12 decibel SINAD. So I'll just take the signal generator off. Does the FM hiss sound right? Yes, FM hiss does sound right. So I'm just going to bring back the 455 signal injector generator. That's 10.695. I want it to be, so it's system load F2. Just want to make sure yeah, it looks like that's on frequency. I'm going to check the front end once again. That looks right. What I'm going to try and do is just talk to Mr. Chippy off the dummy load into the next room. So I'll just see if I can do that with him. I'll just go and have a word with him and see whether he can do that. Right, I'm recording. Mr. Chippy, do you copy?
Yep, Roger. Copy you loud and clear, over.
Roger, that sounds fine. Thank you.
Yep, Roger that. No problem. 10-10.
I think that's that. I think that proves that we've got that right. So it's 0.5 of a microvolt now for 12 dB SINAD. So that's come down a very long way from 5.5 microvolts. So it's a matter of getting the IF 455s right, and I used the 455 signal injection generator to kind of peak those. And we're rechecking the detector. You've got IF at 10.24 from the synthesizer reference crystal, which is injected into the IF. So we have to peak that, and then your two front end ones are there. So it's an unusual design, but they do work well when they've been set up right. But as you can see, a golden screwdriver isn't going to get anywhere with that, and this is why so many of these are messed up. And they think, oh, they're rubbish, those sets. Well, they're not, and they work very well when they're set up right. So that's that. Let's now go on to setting up the S meter for S9. Well, you know what? It's virtually bang on. So I'm just going. I will just adjust it just for your pleasure. So it's the adjustment just there, just to show it. It's about the only thing not screwed up on this set. Then the squelch. So we'll take the signal generator to a lower signal. I'm going to switch the signal generator. Oh no, I'm going to switch the squelch to full. Let's turn it to full, and then I see when the signal generator comes in. I want it to be 100 microvolts to break through when we've got the squelch on full. So we've got 1, 3, 10 microvolts, 30 microvolts, 100. It's not coming through. We see an S9 signal. So I just want to. Actually, I've misset that. I misset the S9. I hadn't got the attenuator right. So we'll just redo that. There we are. So now we want to back off the squelch, and the squelch is the preset. They're all when they're vertical like this. It's just there. So I want to back off that. in actual fact it doesn't go where I want it to be. So when does it come in? It actually comes in at 250 microvolts rather than... But at least it comes in. What you don't want is one of these sets where the squelch never comes in at any point. So we'll do the opposite now, and I'll turn the squelch down to nothing on the radio. We'll turn the signal generator to standby and park it at 0.3 of a microvolt. Set the squelch on the radio to threshold. That's threshold. Switch the radio back on. Sorry, switch the signal generator back on. I've got that in the wrong position. Start again. Switch the signal generator back on. It's just coming in at 0.3. So it's coming in at 0.3. It's leaving about point. Well, making farting sounds, but you lost it about 0.15. So that's sensitive enough to go around scratchy corner nicely. So now you're listening to 0.3 of a microvolt. So that's 1. Let's attenuate it. Without bothering to look at the SINAD meter, although it's still on. 0.6, 0.5, 0.4, 0.3. So you're hearing down to about 0.25 of a microvolt. So it's certainly got the sensitivity now. So I'm going to put it on the aerial. Forgot to look at what time it is. I'm supposed to be on the organ now. We'll see if we can hear any good or bad buddies or indifferent buddies without putting it together.
I've just come in, I've been watching boxing. And then, when
there's a horrible echo on him. Wonder what's wrong with his radio.
I'm more interested in the main event coming up in the next hour, and then I'll be watching that one. On a 45, Sadie Randy, she's the one that keeps the dream alive.
Well, Nana Roger. Well, you can certainly hear them swearing in Nottingham on the burners. So I'll come back to this tomorrow, and at least you've heard it actually receiving. So that's it for today. We'll just put it back together and do the final flick round tomorrow. Right, so the next day I've just screwed that together. We'll unplug the extension speaker, switch the radio on. And it's now on its internal speaker. We'll see whether PA works. So plug in my PA speaker. Testing 1 2. Testing 1 2 1 2. And so it works on the volume control on these sets. Roger bleep. Let's put a walkie-talkie on. Pop it on channel 20. Yep. That's that. It's now 12:30 noon Sunday. One Anna Roger. There's a bit of a lift on today. Now, I was chatting away last night, but I think you heard a bit of that. just before I had to finish doing the video. So there we are, the Communicator NI440DX, and it's the later version. And we'll just put that ready to do an on-the-air test later on today. I think the next repair job we're doing is a realistic TRC 1007. So that's come in for repair, and I know we've got a Binatone Route 66. I know we still need to finish off the PE Ranger from about 4 months ago. So there are one or two things, but you know, time and all that. So thank you for watching, and hope you enjoy the on-the-air test, which we'll record later today.